With Angular v18, now's the best time to start using signals in your Angular applications. And already, a lot of my clients are starting to ask me questions like, hey, Mike, you made NGRX. What do I do about signals? How do I architect my Angular applications around it so that I'm ready for the next 10 years of Angular development? And well, I wish I was some kind of like oracle who could read the future and tell you exactly how this is all going to shake out. But sadly, I'm not. I am, however, someone who's kind of seen state transitions throughout the web ecosystem over the past couple of years. I was there when we got data attributes in HTML so that we could serialize our jQuery state to it. I messed with a bunch of spaghetti code written on top of $root scope, and I saw the advantages that came to React when they included Redux. So what I want to do is I want to have some fun with this. How are we going to predict the next 10 years? Well, let's just do a tarot card reading. Tarot cards should, in theory, give us some guidance as to how we're going to be able to use signals inside of our Angular applications. Now, I do want to be clear. I know it's tarot cards, but there's no magic here. I'm not Magic Mike. I'm just NGRX Mike. So we're going to start with a deck of Oracle cards that I've made specially for Angular applications. And what I want to do is I'm going to draw 4 of these randomly from the stack, and they're going to guide us into how we can architect our Angular applications with signals. So first, I'm going to shuffle them up, and then I'm going to draw just a couple of them out of the gate. I've gotten 8, but I want 4, so I'm going to pick 4 at random and toss them away. And now we have some guidance. What will we do with signals? And we're going to start with that first card. What could the first card say? Well, first, let me introduce myself. My name is Mike Ryan. I'm one of the co-creators of NGRX and an NGRX team alum. I'm a GDE in Angular, and I'm a consultant at Live Love App. So if you want to work with me, you can hire me. I'm also working on Polaris. It's an analytics platform made for developers, launching this fall. Be sure to check it out. So with that, let's go ahead and see what the future is for signals. And the first card that we've drawn is the balancer. Now, this is an arcane artifact from the past. It instructs developers that they should think about the balance between state in their application and the requirements that they have to meet when they're building out their application themselves. So what does this mean? Sorry, 1 second. Let's see. Slide transition failed. Keynote's gotten into an indeterminate state. Of course, who doesn't? Well, let me just fix this real quick. And a kernel panic. All right, well, I'm really sorry. Just give me a second to restart here. It always makes me hungry for some reason. It takes a while. It's awkward that this has happened now, right? I needed Keynote to work, but indeterminate state problems, what can you do? Kernel panics. Okay, we're back. How many times have we had to tell our users, just turn it off and on again? Clear the cache. Refresh the page. This all happens because state is really, really hard to get right. Every system that I've ever used, every app, it's had some kind of crash because they couldn't handle state in a way that was consistent across all devices and for all users. It's critical to the user experience that we architect state right. This is a really well-studied problem, too. One of my favorite papers that I love referencing is one called Out of the Tar Pit by Ben Mosley and Peter Marks. In it, they remark that complexity is the single major difficulty in the successful development of large-scale software. So where does this complexity come from? Well, it comes from 2 places, really: state and how that state changes. If we're not intentional about how we architect our state and our control flow, we're going to create a lot of unnecessary complexity within our applications. So let's break this down for Angular developers. I'm going to choose to use these collection of symbols to represent state. And they're kind of random because every application has a unique shape to its state, right? Someone building a grocery cart app is going to have very different state from someone who's building a map application. And what we do as Angular developers is we're essentially telling Angular how to map from the state of our application into a DOM to render a UI for our users to interact with. Like, this is the core of what we're doing when we're writing components. We're mapping state to a UI. We then have to write code or logic that handles users viewing that state. For example, if they're building that grocery cart app, a user might want to see what's in their cart right now, but also allow users to interact, change, or mutate state, add items to the cart, delete items from the cart. Additionally, we have to write code that retrieves state from some kind of resource. Maybe it's a backend API or a browser API or some IoT device. But this whole flow is what we are always doing as UI developers. We're connecting the system that our backend is built on to our users by pulling state from it, presenting it to our users, letting them interact with that state, and then persisting those changes back. So if we as Angular developers aren't taking the time to think critically about the shape of that state, how state changes, and how it gets persisted, we're going to be in for a load of trouble. So just real quickly, I'm going to show you the demo app that we're going to use for this talk. I've built a simple app that lets me manage my library of tarot cards here. And so I can go through the library, I can increase the count or decrease the count, and that'll form the deck that I drew those 4 cards from. So what's the state of this application at the moment? Well, the state is all the cards that are available to me, which are coming from index to DB, along with the deck that's been created based on the cards available to me and the count that's in them. As a user, I can interact with it, right? Like I could go add a card. Now my state's changed. I'm trying to add a card. Because state has changed, my UI has changed. So we need to architect our state with intentionality. If it's that central to our Angular applications, not doing so, well, we're going to have a slightly different fate than that. We're going to find ourselves really dealing with the spaghetti of it all, and we don't want to be those kinds of developers. So that's the purpose of the balance, or the balancer. It encourages us as developers to think about the balance between state and the UIs that we're trying to build. So let's move on to the next card in our tarot reading here. And the next one is, I knew we were going to get this one because it's 2024 and Angular 18 just came out. It's the conductor. The conductor is this spirit within all of us that wants to use signals today. And why wouldn't we want to use signals? By using signals, we're going to bring a lot of harmony to our Angular applications. We're going to improve performance. We're going to do things with Angular that we've never seen before. But in all seriousness, we should take signals seriously. It's hard to express for me how much of a game changer signals really are for Angular applications. And we're already starting to see some previews of how Angular is going to change and mature as a result of signals. Angular 18 released an experimental API called Provide Experimental Zoneless Change Detection. It's going to let us build Angular apps without including Zone.js. But why is this important? Let's go back to the state graph for a second. As I mentioned, what Angular's job is to know when that state's changed so it can update the UI, right? This function of state is the kind of core part of Angular's rendering process. Angular doesn't want to run this function regularly. It doesn't want to run it all the time because our state is huge, our component hierarchies are huge. It wants to run it only when state's actually changed and something about the UI has updated. But Angular wants to be really smart, right? It wants to know the specific times when to run it. And today, it does that with Zone.js. Zones monitor sources of potential change. It monkey patches the browser so that it knows when the user's interacted with the page or when your service layer code has actually reached out to an API. Now, I have a confession to make, and I'm going to be real with y'all. I think zones are brilliant. I think it's one of the best things that I've seen come out of Angular, and I know we've hit some flaws with them, but I want to tell you why I think zones are really cool. You see, we've built Angular apps successfully for the past decade on top of zones, so they must not be that bad in the first place. But also, one thing that zones let us do is they let us choose how we manage our state. Up until now, Angular has had no opinion about how state was managed. Instead, Angular has cared more about why state might change. This has led to a proliferation of amazing ideas over the past decade, from NGRX to NGXS to Akita to ELF. There have been so many different approaches in managing state for Angular applications because Angular's given us the freedom to go express that. Are there downsides to zones? Yes, obviously, right? Otherwise, we would be trying to replace them. And the 2 downsides, in my opinion, especially as it relates to state, is first, not all sources of potential change cause actual change. The key word there is potential. There are a lot of events that arise in our application that require or cause no state change whatsoever. Second, not all APIs in the browser can actually be observed by Zone.js. Native async await is a great example of an API that zones just can't know about. Signals promise to fix this because for the first time, Angular now has an opinion about how you store your state. It asks you to store your state inside of a signal. And in exchange, Angular will be a lot more intelligent about when it actually needs to run this function that produces or updates the UI. When that state changes, by writing into a signal, it knows to go ahead and refresh the DOM. So let's see what this looks like in action. So I've got this application here, and let's just talk about first this little increment and decrement button. I want to know how often Angular is running change detection when I press this button. So I'm going to go ahead and open up the library component here, and I'm going to implement the doCheck lifecycle hook. And I'm going to type, my fingers are cold. There we go. ng doCheck, and inside of here I'm just going to console log out that change detection has run. I'm going to save this and go back to the app, and you can see that it ran a few times to refresh the page, but let's see what happens when I actually click the button to increment it. Change detection ran 5 times to update just that one number. That's 4 times more than I would have expected it to have run. So what's going on here? Well, when I clicked that button, state hadn't actually changed yet. Instead, what happened is my component received that event, and it dispatched an action to my NGRX store. That action is what actually caused the state to change. It increased that value and pushed it down into my components. I handled this update optimistically. I persisted it to indexed.db. So even though my state's finished changing, in the background, some additional work is happening. I'm opening up a connection to indexed.db. I'm fetching that card out of indexed.db. I'm increasing the count and persisting it back. And so even though I only clicked one button to increase one value, change detection has run 5 times as a result. Because remember, zones only know about potential sources of change. And zones don't know whether or not these other 4 red events actually caused a change to happen. Signals are smarter. So let's go ahead and take a look at what this would be like if we tried to use the experimental zoneless change detection. To do that, the first thing I'm going to do is I'm going to go to angular.json, and I'm going to do something that I've been waiting to do for a very long time. I'm going to hunt for zone.js here, and I'm just going to get rid of it. And that makes me so happy just right out of the gate. I'm then going to go ahead and restart my Angular server. That way it knows. And by the way, note that the polyfills was like 88 kilobytes in the dev server. Once I go ahead and restart my server, polyfills will be completely eliminated. So I've already saved like 88 kilobytes. That feels like a win to me. But the next thing I need to do is I need to go into my apps configuration here, and I need to go ahead and provide zoneless change detection. With that, I'm now telling Angular, or making a promise to Angular really, that my entire application is either using the on-push change detection strategy or signals from my state. Because this application adheres to that promise, I can now opt out of zones in my application. If I go back to it, clear, refresh, Angular requires Zone.js. No, we don't require Zone.js, but we'll restart the dev server just in case there's something that happened. So now that we've rebuilt it, don't have zones, we've configured, provide zone experiment, I see what I did, experimental zoneless change detection. The application is now running, and when I increase the count, change detection ran once, because state changed exactly once as a result of pressing that button. So beforehand, where change detection was running every single time an event was firing, now change detection only ran as a result of that action being processed by NGRX store. NGRX store pushed a new value into a signal, Angular knew to refresh, and that's all I needed to do. Beyond that, stack traces just get so much better. Like, I'm so ready to not be reading stuff like this anymore and instead read something like this that actually helps me debug my application. This is what's going to help me write better Angular applications, is the increased debugability. And so that's the spirit of the conductor. It encourages us to go ahead and start embracing signals. They're so much better when it comes to change detection, performance, and debugability. So what comes next in our tarot card reading? The mirror. The mirror is another one of those ancient artifacts. It guides us as Angular developers to make sure that we're not duplicating state through our application. It encourages us instead to lift state up, to share it inside of a shared container. You see, now that Angular has a built-in state management system with signals, I've already started to get the question, like, do we still need NGRX? And I know a lot of you are probably itching to get rid of it, but the answer to me is yes, absolutely, you still want a state container. Maybe it's not NGRX, maybe it's one that you prefer, but you're still going to want to have some mechanism to share state throughout your components. I want to tell a little story about my phone and my least favorite app that I use every day, and that's Slack. I cannot tell you how many times I get a notification from Slack telling me that I have a message to read. And then I go read the message, and I go back to my home screen, and that red dot is still on my home screen. It drives me crazy. And this is a state problem, because what's happening is that the two sources, or the single source of state, whether I have unread messages, isn't being shared between that little red dot and the actual application itself. In fact, this particular problem is so pervasive that this is where Flux and eventually Redux came from. You see, when Facebook was building Facebook.com, they had that little messenger icon on the top right, and then they had the messenger windows at the bottom. And their users would encounter this exact error. They'd interact with a message, but the notifications wouldn't stay in sync because the state was not being shared. It was being duplicated across the application. And so we still will need state libraries. Signals don't give us an opinion about how we share state. It just gives us a better tool to represent state values. So in this little demo application, every time I increase this counter, we should see the deck on the right update. And if I refresh the page, we'll see that it does update, but I had to refresh the page to get it to work. That's not what I want. That's not how I want this to work at all. So why is this the case? Well, a different team or a different developer wrote the deck component and didn't realize that the list of cards was already in a shared state container. So instead of trying to reach for the state in the shared state container, they chose to go ahead and just call indexDB and get the state or list of cards back out. If we want to fix this, we can instead get rid of this entirely. And I'm going to go ahead and inject NGRX store. From there, I can read out the deck using this .store.select signal. Don't know if you knew this or not. NGRX store has support for signals. You can now select values out of the store as a signal. And I'm going to select the deck of cards from my state. I'm going to go up to my template real quick, get rid of the async pipe and the $sign, call my signal. I can even drop a few things out of here. I can get rid of this part there, get rid of the async pipe, simplify some code. And now when I go back to my application, as I increase or decrease cards, we can see that the state on the right that was built entirely separately is responding to it in real time. So what should we do as Angular developers as we're architecting our state management? Well, I don't think a lot has necessarily changed in terms of the libraries that I want to recommend to you, with the exception of a couple of new libraries built by the NGRX team. First off, for your truly global state that's used in so many places it would be hard to share it any other way, continue to use something like NGRX store, a global state container. But for the rest of your components, I highly recommend something like Signal Store. In fact, if your application's not too terribly interactive, you can get away with using Signal Store for your entire application state. Use Signal Store for the majority of your DOM or your component hierarchy to share its state. And at the very edges, that's where you'll want to use Signal directly. When in doubt, start here. Use a signal. And when you're ready, lift the state up as needed. Once you find that you need to share that signal a little bit more than you really want to, put it in a Signal store. When you realize you want to share that state across a lot of different Signal stores, lift it up into your NGRX store. That's going to guide you as to when you're going to need these different libraries in your application. So that's the mirror. Just because we have signals doesn't mean we want to avoid using state containers just yet. The final card in our tarot reading is the flow. Now this is a guiding spirit within our Angular applications. It instructs us to be careful about the way that we orchestrate our control flow. Remember, it's not just state that leads to complexity, it's how that state changes that's going to introduce new complexity as well. And you can think of signals as a built-in reactivity primitive. So another really fair question that I think is worth asking, and I see it being asked on Twitter already, is do we still need RxJS as Angular developers? And again, for my money, the answer is absolutely yes. I'm not going to read this entire tweet. I really encourage you to go find it, but Ben Lesh did a really great write-up of why observables are so powerful for web development and async programming. But I want to highlight one part, which is that async programming is never easy. It's never easy, and it's never straightforward. The only way you can make these things seem easy is if you handicap the user experience of your application and make the UX bad for your users. Let me show you what I'm talking about. So in the United States, we have this really popular food ordering app called DoorDash. And I'm going to place an order for some Taco Bell. Please don't judge me. Maybe I have a hangover or something. It's just what I'm feeling right now. And I want to make sure that I want some sauce packets. Now, I need like 20 of these suckers, so I'm going to go ahead and add 20. This is a real like multi-million-dollar app that millions of Americans use, and this is how painful it is for me to get up to 20. Because they've had to deal with the complexities of asynchronous programming, this UX is just really, really bad. It's hard to do right, and I'm sorry, DoorDash, I hope there's no engineers in here. It's not done very well, at least not on the web. But what makes observables great is that they give us the things that we need to build better user experiences than what DoorDash is doing. It gives us a means of controlling concurrency, of handling cancellation, of producing multiple values from one construct, and composing them together using operators to create really novel means of expressing async logic. So just because I wanted to, that's why I built that little increment and decrement thing into this app. So you're probably wondering, okay, how does this work? How did we manage to make this happen? I'm going to go into my effects here real quick, and I'll show you the effect that does it. It's really simple RxJS, in my opinion. I'm listening for whenever the user increments or decrements a single card, and then I'm using the concat map operator to make sure that A, they all happen, B, they happen in order, and C, I can handle errors one at a time if any of these things actually fails and retry them. I cannot think of an easier way to write this complex of asynchronous code any other way in JavaScript. So do you still need RxJS? For my money, absolutely. There's nothing better for it. So if you're building an application today, where would you use RxJS? Well, of course, I still love NGRX effects. It's a great way to describe your asynchronous control flow at the top of your application. But thankfully, Signal Store also lets you describe side effects using observables. So if you don't want to use NGRX Store and you just want to stick to something a little bit simpler, NGRX Signal Store is a fantastic pick for this because you can still use RxJS directly in it. And then sparingly, and I mean very sparingly, use the new effect function inside of Angular. And I say sparingly because the Angular team's definition of effect is just slightly different than like a state library maintainer's definition. There's nothing wrong with the two definitions, but really you're going to want to use that effect function when you're trying to like take a signal and write its value out to like a DOM API, maybe a persistent local storage or something like that. You're not going to want to use it for network effects. And just like we did for state, lift effects up as necessary. You can start small and then graduate to the more heavier libraries as your application needs it. So that's the flow. And this guides us in our journey into integrating signals into our Angular applications and architecting successfully the next 10 years. We want to balance between the complexities of state management and control flow. We want to use signals today. There's no reason not to use them. The big state libraries already support them. Angular supports them. And I promise you, Angular's going to get better and better if you're using signals. Like, I can't wait to see what they do with partial rehydration, for example. Make sure that just because you're using signals that you haven't lost sight of the fact that we do still need state containers. There's a place for NGRX and all of its variants out there. And then finally, don't abandon RxJS. It's amazing. It does things that no other asynchronous control flow pattern can do in JavaScript. With that, thank you so much for joining me. It's been a real pleasure. This has been your tarot card reading. Code, slides, go get it. It's all available to you. Thank you and have a great day. Woo! Woo-hoo!